slides? Is it just the next slide? Okay, good to go. Great. I'm Jake Vierzen with R Value Homes. I have been building ICF homes as a subcontractor since 2004, and 5 years ago I switched over to being a builder, mostly due to frustration finding builders who wanted to work with insulating concrete forms. With Eric Hughes from Image Design, we did work on the prickly pear sanctuary that he introduced to you earlier. I have to give a mea culpa. I intended to double side print these handouts and save about 40 or 80 pieces of paper. Clicked wrong, sorry about that. I gave you a handout instead of a slideshow. I prefer to have something to hold on to, and perhaps some of you do too. I'll probably be covering a lot of the same ground as many people have before. I take that as both good and bad. It's good because it means that we're probably on the right track. Bad, you might get bored. Sorry. So some late additions that didn't make it onto your handout, and I can't believe I missed this, but all electric. You want to build net zero, you build all electric. You can't get rid of a gas bill with photovoltaic panels. Next would be using thermal mass. That did get briefly touched on here, but using thermal mass can help mitigate peak loads. So on those days where we have the wild temperature swings, which actually happens here quite a bit, spring and fall, we have wild temperature swings. Thermal mass can even out the peak loads so that you don't need HVAC, provided you have enough thermal mass. And then before I launch in, I have to say there are lots of ways to get to net zero. There are a lot of good products out there. There is no formula. Every home we build, we have to look at on a case-by-case basis. We can't do everything the same on every home. So there's no silver bullet. There's no magic way to get there. It takes thought and it takes planning. But in full disclosure, we do prefer insulating concrete forms for most of our applications. Okay, according to Dr. John Straub of Building Science, energy bills have increased at twice the rate of inflation over the last 40 years. That and a host of other reasons do make it plain that using less energy is better than using more energy. I'm probably preaching to the choir. Dr. Straub, again, he writes, generating clean energy on or near the site is another obvious approach to reducing environmental impact over a build's lifespan, but second in priority to using less. Emphasis mine. Second in priority to using less energy, meaning our first priority is using less energy. Again, this has been said before, but it's extremely important. During new construction, we have a great opportunity. So yeah, I don't do remodels. Hopefully there are people out there doing remodels and deep energy retrofits. That's not me. I won't be speaking on that. But during new construction, we have a fantastic opportunity that we'll never have again. We can create a home that's going to sip energy and outlast other homes at a much lower cost than attempting to upgrade a home later. Some parts of the home are simpler to upgrade later than others. Appliances, mechanical equipment can be replaced pretty easily. Attics can easily have more blown insulation. Unfinished basements and slabs can be insulated more later pretty easily. Walls and windows, these things are very difficult and very expensive to upgrade later. So if, like most people, you have a budget and your budget prevents you from doing everything you want to do in the home, the wise strategy is to implement now only the things that are expensive and difficult to do later. Build good walls with good windows, mechanical ventilation, and air sealing. You can add more attic insulation pretty easily later. You can replace equipment later pretty easily, and you can add more PV later. So focus your budget on the choices that can't be easily or inexpensively changed later. And another thing to consider here too is technology is changing all the time. T-Stud just came out within the last year, to my knowledge. Fantastic product. Uh, who knows what new products might be out there later that you can upgrade with for your mechanical equipment, for instance. But the industry is changing a lot, and it takes a lot to keep up with it. But on the plus side, offsetting and doing some of the upgrades later, there may be better technology available by that time. So it's not always bad. Some general principles for our approach. First, do no harm. Sounds a little bit like the Hippocratic Oath, but I think it applies to builders too. When we're building homes, we have to, in my opinion, think about what is right for the client, not what is right for our bottom line. I appreciated the comment earlier, which I would echo. A code-built home is the worst home you're legally allowed to build. It's the bare minimum that's considered acceptably safe. It should not be our benchmark. Structural integrity comes before energy efficiency. Probably makes a lot of sense, but we don't often think about it. We often will put our dollars into what's sexy and not into what matters. We want our homes to last, and we want them to be safe before we make them energy efficient. Health is the next priority. Let's not build petri dishes. And let's face it, over the last 40 years, a lot of homes have become that. Particularly once we started tightening homes up, we just started discovering all new kinds of mold in our homes. One of the reasons this happens is because as we start tightening homes up and insulating them more, that means that there's less air movement through the wall and ceiling assemblies, and there's less energy movement. That means the walls and ceilings don't dry out like they used to. 100 years ago, homes had no insulation, and if they got wet, which they did, they could dry out within a day. The amount of heat moving through it and the amount of air. That doesn't happen anymore. So once we started tightening those homes up in the late 80s, that's when we realized that we were creating problems with drying. So it's really important that we build walls that have the ability to dry. Yes, absolutely, it's important to keep them from getting wet, but we can't do that perfectly. We live in a fallen world. It's going to get wet. We have to build walls that can dry. We need to understand vapor drive. We need to understand dew point, perm ratings of the materials, and how these things change during the seasons. So a popular approach has been to add an inch of foam to the outside of walls. This usually creates more problems than it solves, because what you've done is you've reduced, again, the amount of air and energy moving through the wall, but you haven't added enough insulation on the outside to prevent condensation. Condensation is like you pull that pop can out of the fridge in the summer, set it on the counter, and it gets wet. That happens inside our walls. I'll get into that a little bit more later. So in addition to building a home that's healthy, we need to focus on durability, long-lasting homes, homes that don't require excessive maintenance to keep up with. An efficient home that needs major work in 30 years is not a home worth building. 2 years ago, for one of our clients, we tore the siding off their 2007 home, and we added insulation, replaced windows, and re-sided. We also replaced about 30% of the sheathing, which was completely rotted. This was 2 years ago, so 2017. The home was only 10 years old. 30% of the sheathing was completely rotted. They had no idea. We need to build homes better. Finally, after those things, efficiency is something that we consider. Efficiency is important, but it's not as important as safety, it's not as important as health, and it's not as important as durability. And then finally, comfort. Comfort is a wonderful thing, not quite as important as efficient, but our approach is that when we focus on building a home that's comfortable, we do get health, comfort, and durability, and efficiency is the natural result. Step number 2 for building a net zero home or net zero ready, understand the local climate. As I mentioned earlier, there isn't a one size fits all approach. Different approaches need to be taken in different climates. The code has 6 or 7 distinct climate zones that I'm aware of, but there's also local considerations. Humidity, dew point, average temps, extreme temps, degree days all play a role in the decisions that you're going to make. Living on the lake shore versus living in Lansing is going to have very different considerations. When you're choosing your build site, you have, again, a great opportunity here to do well. Choose to build passive solar. Find a site that allows you to focus the long axis of the home east to west, so you have a large southern exposure. Designing for passive solar heating is free energy. It takes very little work. It's extremely low-hanging fruit. And I can speak from experience, even when it's 5 degrees out, your home's heat will not run on a well-designed passive solar home all day. So south-facing, not extremely shaded. These things are important. You have opportunity when choosing your site to pick these out. Another thing that just practically, sandy soils are awesome. You're going to spend thousands more on a clay site. In addition, sandy soils help keep the footings dry. Wet footings are going to wick away energy. So if we have a clay site, we're going to find a way to keep that footing dry. Next is air sealing. I have air sealing as more important than insulating, and hopefully that's a common refrain. We need to drill that through our heads. Air sealing is more important than insulating. When we wear a jacket that's shredded, it's not going to do us a whole lot of good. A windbreak over that is going to do a lot of good. Air sealing is more important. But an airtight home doesn't happen by accident. We have to plan ahead for it. In fact, we have to plan ahead a lot for it. One of the strategies we use for air sealing is to separate the air and thermal barrier. It used to be we considered the thermal barrier or the insulation the same thing as the air barrier. It's not. They're separate. I'm sorry. We need to plan them to be separate. Another thing is a continuous air barrier. Watch the transitions. Foundation to subfloor, subfloor to walls, walls to windows, walls to roof, cantilevers, bonus rooms. All these things are typical points where we have major air leakage. What I would recommend is what's called the pen test. You take a cross section of your home, you put your pen on the air barrier, and you should be able to trace it all around the home without ever having to lift it. If you have to lift it, you've got a problem. So continuous air barrier, use the pen test. Also on on air sealing, account for seasonal movement as well as drying shrinkage. Account for seasonal movement of the home as well as drying shrinkage of the materials. So your air barrier needs to be flexible enough to handle this. Allow for drying of entrapped moisture. Again, our walls are going to get wet, possibly even our ceilings. Allow for drying of entrapped moisture and account for seasonal changes in the drying direction. In the summer, with air conditioning on, the home is going to dry to the inside. The walls are going to. Winter, it's typically going to dry to the outside. But again, the sun can come up and change the direction of that vapor drive. Watch for holes in the air barrier. We get holes in our air barrier through structural members. For instance, cantilevers, porch supports. We also get them through electrical and plumbing penetrations. We get them through windows and doors. A mechanical chase, somebody called it something different here earlier. Service cavity, I think. Mechanical chase or service cavity is a great plan. So you have your air barrier, and then inboard of that, a false stud wall or ceiling is built where all the wiring and plumbing are run, electrical boxes and so on. Recently on a project, we saved over 150 penetrations through the ceiling air barrier by using this strategy. Also on windows and doors, it's a good idea to spend a little bit more again here. This is not something that you're going to easily change later. Good windows and doors have multiple seals and multiple latching points. Finally, or not finally, but next would be insulating. And much like I said, use a continuous air barrier, we want our insulation barrier to be continuous as well. The same principles apply as they do for the air barrier, including the pen test. Something that Mr. Brian, alluded to and breezed through pretty quickly is parallel path heat flow. Also, we call them U value calculations. So probably most of us are familiar with R value, and oh boy, 5 minutes. Uh, yikes. so, so yeah, sometimes we think that we can just average out R values of our wall assembly and get a performance of that wall. It actually doesn't work that way. There's something called a parallel path heat flow. That's what he was showing you with those spreadsheets. For instance, you could take a theoretical wall, 2x4, 16-inch on center, insulate the cavity to R100, and the actual performance of that wall is around R18. So parallel path is important when you're designing your wall and ceiling assemblies. We don't want varying thicknesses of insulation. We want even insulation. Huge R value numbers aren't always needed. Consistency and attention to detail is what's needed. Energy modeling, very helpful. I put that down here at the end with installation, but again, we're still in the planning stages. We haven't even started construction. So energy modeling is pretty important in the planning stages. Moving into building, we have a lot of decisions to make again. Well, I guess we're still at design. Basement or frost-protected shallow foundation. Think about how you're going to use the house in the future. Should I become old, which is really likely to happen, am I going to want a bunch of stairs? Do I have the opportunity now to build a house that's barrier-free? If I have a basement, where's my water table at? Am I going to be fighting that? A lot of people build basements and then don't finish them. That's a lot of dead space. If we don't circulate air through there, then we're creating, again, moisture and mold problems. If we're going to circulate the air there, that means we're conditioning that air. That means we should be finishing and insulating that space. So we got to think about this stuff ahead of time. Keep your footings dry. There are a few different strategies for doing this, but don't dig a hole in wet clay and pour concrete in there and think you're going to have a comfortable foundation. Keep your footings dry. Foundation walls, we like to keep the walls warm so they don't, again, like a pop can, condense moisture. I'm sure most of us have had the experience of walking in somebody's basement and feeling a chill and feeling damp. Keep the walls warm and we don't have that problem. And then I'll have to end here with keeping the slab insulated edge to edge, as Ryan showed in his pictures. We don't want our concrete slab touching the concrete footings or the concrete walls. It needs to be set up like a bathtub. Concrete is completely insulated. Thank you for your time.
Thank you, Jake.